we're back. We're back in business. Okay. So find the circumference
3, 2, 1, action.
of circle S with area of 9x squared pi centimeters squared. Okay, so we're trying to find the circumference of a circle given a certain area. Maybe challenging enough on its own, but then you're going to add in some variables, and I'm going to ask you to leave it in terms of pi. Meaning, pi is just another variable. Don't multiply it out. We all know what it stands for, 3.141 whatever. It's not a number that we want to use. We want to keep it in terms of pi, meaning don't multiply it out. So the area has the pi value inside of it. So it looks like this. Area of a circle, start with that formula, pi r squared. Now I'm going to replace what I know. Do I know what the radius is? No, but I know what the area is. The area is 9x squared pi.
That's blurry.
Oh, sorry.
I got it.
Save the day. I think my camera is going out. It's not very receptive to that. All right, so if I wanted to get pi out of the equation, listen, I usually don't want you to sit in the back, but I might move you to the back.
Really?
You cannot leave.
No, I need my wish.
Leave my people alone. Here, we'll put it here.
Oh.
Okay. All right. Here's the deal. If I want to find the value of the radius, because I'm going to apply that to the circumference, if I want to take out of the area formula the radius, how can I make that usable for the circumference? Okay, so the radius of this formula is going to be found, but the circumference is asking for diameter. So what would I do to the radius to be able to get to the diameter? Double it. Okay. So I want to find what r is equal to. So start by just canceling pi out from both sides. Drop the pi out of the equation. Both sides have one, so you can divide evenly. If 9x squared is equal to the radius squared, how do I get what r is instead of r squared? Good. Square root it. Perfect. So the radius is 3x. The radius is 3x. Okay. Now, the weird thing about this is pi does not go first in the answer. In terms of pi, means leave pi at the end. So when I have pi in the beginning of circumference formula, it truthfully, for my final answer, should be circumference equals 6x pi. So in terms of pi, usually the pi goes at the end. I'm not going to lose a whole lot of sleep about that if you accidentally modify that, if you put it in a different order. I am going to care about the units. Is it a label of units squared or just units? Units. Just units. Okay. So that's it on circles. I'll do more practice questions. You'll see more in the homework, but I'm not going to do any more right now. Let's get into the fun stuff. Apathon. Remember this from your notes on Friday?
I remember the word. I don't understand what it means at all.
All right, so here's number 6 right off the homework. I'm going to kind of do questions for you in the assignment 1. Each question takes about 10 minutes, so don't get too excited. We won't get through much. But I'm going to do question 6 with you right now, and then I'll see if I can help you through number 8. You'll work on that with a partner in a minute. So start by drawing a 6-sided figure, please. Make it nice and big. This is number 6 off the homework, yeah. Six-sided figure is called what? What is it called?
Stop sign.
Hexagon. That's an octagon. But.
Same thing. That's why I read.
Okay, there are two things you need to know. You need to know what a radius is, and you need to know what an apothem is. A radius is what you're going to be given on this question. Your radius length goes from the center to the side of the, or to the vertex of the shape. This is a radius. An apothem, everybody say that. Apothem, good. An apothem goes from the center to the side, middle of the side length. An apothem is what we think of as the height of a triangle. Okay. So I have how many total triangles inside this shape? Okay, let me erase this and ask that question again. How many total triangles are inside in the shape?
5, 6.
6. So it's directly related to the number of sides. If you have 6 sides, you have 6 congruent triangles. Assuming it's a regular polygon. A regular polygon is the same everywhere. If I have 5 sides, a pentagon, how many triangles are inside my regular shape? 5. Okay, so it's related to the number of sides. Your task is to find the area of one triangle and then multiply it by what? 6. That's how you get the area. You find one triangle and you multiply it by the number of triangles there are. The problem is the given information isn't super helpful in finding that area. So you have to do some work. I'm going to give you steps. If you're a step person, write these down and use these as you do every problem. It'll work for all of them. There are 3 of them. First step, you're going to find the angle. So you do this 360 divided by n, and then divided by 2, which I know seems silly, but I have it written like that for a reason. All right, a central angle comes from the inside of this shape, right in here. 360 divided by n.
6.
Good. So 360 divided by 6 is what? 60. That's this angle right here, 60 degrees. But the problem is I don't want that big angle. I want half of it. So I want to divide 60 in half and get 30. Yep. So what I want is 30. All right. Just because I like extra space, I'm going to go big on this one. You can join me if you want. You don't have to. I'm going to take out this little triangle right here and blow it up. So this is 30 degrees.
You know it's a right angle.
I know it's a right angle because by definition the apothem meets at a perpendicular angle. Okay. Yep, we could sure label that. The hypotenuse is 10. So we need to find the area of this triangle down here. The area of a triangle is 1/2 base times height, right? We've done that already. We have a base and a height pulled out. That's why we're doing that. We're pulling out.
Oh, we're going to do this side.
Yeah. Okay. So we're pulling out the half triangle because we can do trig on it, but not just trig. I made you listen to that other song for a reason. Step 2 has 3, 4, maybe different options. Trig. Some people just do trig no matter what. They're never going to do the 30, 60, 90 rules, and I get it. I'm not going to force you. Trig will work every time, okay? But in case you are challenging yourself, ready for that, you will use the 30, 60, 90 and the 45, 45, 90 rules from time to time. So I could use 30, 60, 90 rules, right? Because I'm working in a 30, 60, 90 triangle. X goes where? Short side, long side, or hypotenuse? Short side, which is down here. My blow-up picture doesn't look very good, but you could see it in the smaller one. X goes here. 2x is where? Hypotenuse or the long side? And then x root 3 is the long side. So 2x and x are just one double the other. This is twice as long as the short side. So if this is 10, how long is the short side? 5. If this is 5, what's the long side? Yeah. So this is 5, and this is 5 square roots of 3. So step 3 is just to actually apply the formula. 1/2 ASN. All right. 1/2 AS is the area of the triangle, and then N is the number of sides. So N is correlated to the number of triangles there are. So apothem, how tall is the apothem? So 5 square roots of 3. The apothem is the height of the triangle. The apothem is 3. Oh, sorry about that. What's the side length? This is 5. What's the side length of the whole triangle? 10. So this is 5, but this side length is 10. I'm going with a third color, fourth color. Wow, I'm really highlighting well today. That 10 is pretty key though, because I get a lot of people plugging in their 5, which I totally understand why you're doing that. You don't miss all credit, but it is partial credit. And then the last number 6 sides, and you just multiply that out. 1/2 times 10 times 6 times 5. $150 square root of 3 inches squared. I do not care if you were to type that into your calculator and give me a decimal. I would take it. I'm not going to be particular about that. Okay? But here's at least one.